Hello, welcome to India's most comprehensive e-learning platform BYJU'S Exam Prep, and also special welcome to this wonderful series. As you all can see on the slide, currently we are going to start GATE Champion series, and as a part of this discussion, we are about to discuss 500 most important questions. Very important number. This is 500 most important questions, and it is a usual tendency for everyone that when I tag like most important questions, you may feel that the expected questions will be discussed. No, most important questions in the sense we will extract the maximum concept out of the question in such a way that we will be able to cover the entire syllabus in the less number of questions, and a single question can be converted into multiple questions. I am very sure those students who are regular to this course, you will love it and you will enjoy it, and I am very sure you will going to get a very good rank. Clear? So as we are going to start this series, I want you to maintain the same momentum till the end of this particular series. As I was saying, we are going to discuss 500 most important questions which cover the entire syllabus of GATE examination, including all 10 subjects. So guys, are you ready? Yes, Rajshekhar, one of my favorite students, good evening. Hema, good evening. And Rufina Begum, good evening. Isha Agarwal, good evening, every one of you. So there are some regular students I like, right? Prasad, good evening. Well, are you guys ready? Ready to go for the champion series or not? 500 most important questions. As I said, don't keep your mindset in that way that the questions what we are going to discuss now, you will going to get the same question. No, the idea of having the champion series is to make you understand how well you can extract multiple concepts from a single question. Okay, right? Very good evening, Mohan Sai, good evening, Shashil, good evening to all of you once again. So before going to start the actual session of today's lecture, because this is the first subject in this great series, that is champion series, so let me quickly introduce about myself, because some of the students is this session have all subjects. Yes, Saman, we are going to cover almost every subject. Okay, so be with us till the end of the series, then you will going to love it. Okay, right? As you all can see, myself, Phanindra, all put together, I have an experience of 12 plus years teaching industry, and coming to the main point that I myself have topped the GATE examination almost 11 times. Up to now, I have guided more than 50,000 students in the subjects of circuit theory, control system, measurement, and industrial instrumentation. So guys, before going to the actual discussion, I just want to tell you the schedule of the first subject, that is circuit theory. Good evening to everyone. Wow, very good response. And it's really amazing to see such a great response, but you please maintain the same momentum till the end of the session. I'm very sure you will going to get a lot of information out of the subject. Clear? So the first class is today at 9 p.m. We have already started and we are in the discussion now. I will try to cover the basic techniques. In fact, the questions on the basic techniques, even though it looks like basics, I will teach very differently so that you will really enjoy. And in tomorrow's lecture, we will going to discuss about the theorems, which is very important. Followed to that, we will see transients, and then we will also see AC analysis along with the two-port networks. In fact, I will try to cover maximum number of concepts in 4 lectures. Again, I am saying that don't keep the mindset that you will going to get the same question what I am going to discuss. Clear? Right? Yes. So somebody is asking a very good question. Sir, how do you manage vocabulary and grammar, sir? Say, Ravi, I will give my phone number. You can contact me separately because English is English. Okay? Right. So let's go straight away to the very first question of the day, because we have very less time. So I don't want to waste the time. So let's see the statement of the first question. Every one of you take pen and paper and try to solve along with me. And I'm very sure if you try to solve along with me, not only you, even I will also enjoy. Correct? So the first question is, the current I of t, look at the statement clearly. Current I of t means the current with respect to time is sketched in the figure, flows through the element. We don't know what is the element. Maybe there is some conductive material and the current is flowing through the conductive material. We all know that the current is actually nothing but the flow of charge, right? Somebody is asking this question. Sir, this is only live? Yes, this is absolutely only in the live. Okay, right. So the question is, what is the charge exactly at 5 microseconds? This is a good question, I would say. In fact, it was a previous GATE question. but let us see how we can solve this, right? So you require to find out what is the charge at 5 microseconds when the current waveform is given to you. So whenever you find this question, don't try to apply, jungle mangle and use muzzle hustle puzzle work. So simple thing is apply common sense. What is current? Whatever may be the material, this current is going to be written as, or else when the current is flowing, has to be written like rate of charge, right? So dq of t by dt. If you are an engineering student, that too if you are from ECR, electrical or instrumentation, somebody has given already the answer, but it's not correct. So please look at that, right? So if you take the current expression, being a electrical student or electronic students, instrumentation student, you already know this formula. But how do we use this, correct? So rate of charge is nothing but current. So from this we can say that dq of t can be written as I of t into dt. This is the first step every one of you can write, correct? Now what they are asking, what is the charge at 5 microsecond? Clear? So and the graph, if you see, it was clearly mentioned that the time is in microseconds and that is on x-axis, and in y-axis you have current in milliampere here, correct? So easy. Now the time is all the way started from 0 up to 8 microseconds, the graph is there, and here current is up to 6 milliampere, correct? Now the question is, if you want to find out up to 5 microsecond, how do we do, right? So 0 to 5, correct? So in fact, I would like to say it is not going to be 5 here, rather you must actually write this as a q here, clear? So because we require up to 5 microsecond, right? So Ravi Shankar has already given the answer. We will see whether that is correct or wrong. All of you please try to keep pen and paper with you along with the calculator. Every one of you should solve this question, okay? So here you must keep 0 to 5 microseconds, correct? So let me write down 5 microseconds here. But if you go with the integration, you must understand the fact that 0 to 5 microsecond, the graph is very different, correct? At different interval. It will naturally take some time because you can find the I of t expression and then use the I of t expression mathematically here and then solve the integration, and when you solve the integration, then you will going to get the answer. I am very sure it will at least take 5 minutes of time or at least 3 minutes of time, even if you are very strong. Now how do we solve this one? Any other answer? So some people are saying B, some people are saying C, right? Rufina is also already given C as the answer. The easiest way is, instead of going to use a formula, it is better to apply common sense. See, the charge here, Q, can be written as integration of 0 to 5 microseconds, particularly I of t dt. What does it mean? It's the integration. Integration means accumulation, or it is the area under the curve, correct? Area, very good. I love that, Krishna, very good, right? So area under the curve, right? Now you see here up to 2 seconds. If you see, this is a triangular area, correct? So look at that, this is the triangle, correct? Up to 2 seconds, it is a triangle, right? So up to 2 seconds, up to 2 microseconds, what is the area? So it is the area of the triangle here. So area of the triangle is half into b into height, correct? What is the base here? Base is 2 microseconds, correct? So let me write only 2 here because we already know time is in microseconds. What is the height here? Height is all the way from here to here, correct? So what is the height? 4 units, right? So all put together, if you multiply, because 2 will going to get cancelled, you will be having only 4 and this will be equal to 4. Let me keep 4 itself, right? Because we are calculating the area, it means that we are going to get only charge as a coulomb here, right? So 4 coulomb is going to be the value here. So how many of you are giving triangle and rectangle? Good, very good, right? So and then from 2 microsecond, so let me say next value is what? So those who have completed, just wait for the other students because everybody has to do it, right? I am a teacher, I am not a student. So I need to explain to everyone such that everybody will enjoy it, right? So from 2 microsecond to 5 microsecond, what is the situation? Now if you see from 2 microsecond to 5 microsecond, first let me erase the previous data here, right? Right. So now you see from 2 microsecond to 5 microsecond how the things are looking like. So I am very sure from 2 microseconds, especially from here, it is looking again a triangle, correct? So from here to here, isn't it? Correct? So but how do we find out the things? So it is again a triangle here. Either you can make it as a triangle and rectangle, because you must understand here you need to take up to 5 only, correct? Up to 5 only you need to take. So what we should do? So if this is going to be rectangle clearly, so this box is going to be rectangle, and above that we are having a triangle here, correct? So that means 2 to 5, there are two different areas we need to make it, correct? So yes, so what we should do? So 2 to 5, first we have to find the triangle area, and along with that we need to find out the rectangle area also. Now what is the triangle area here? So let me take another color here. So please see here. So this is a triangle, isn't it? So again, this part is only triangle up to here, this blue color one. So I can say this as half into base into height. What is the base here? Base is almost from here to here. So that is 2 to 5. How many units? 1, 2, 3. 3 units, correct? So therefore I can say half into base into height. What is the height here? So from here to here, that is 2 units. So this is the area of the triangle all put together, plus area of the rectangle is how much? First of all, where is the rectangle here? Rectangle is here, correct? So this is your rectangle, and again base is 3, and again the height here we can see length and width, this is going to be 2 units, correct? So therefore I can say this as a 2 into 3 units. That is very simple here. 2 into 3, all the way it is going to be 6 here, correct? So now you tell me what is going to be the overall area here? 2 into 3, 6, plus this 2 will going to get cancelled, and all the way it will become 9 coulomb here, right? I think 9 nanocoulomb here, 9 nanocoulomb, and 9 nanocoulomb plus 4 nanocoulomb here, correct? So what is the total value? Now the total charge is going to be 9 nanocoulomb plus 4 nanocoulomb. All put together it is going to be 30 nanocoulomb. That is option C. So many students have got the answer. Good evening Naveen, you are so late. Kaushika, option C, right? So I'm very happy to see many of the students have got the answer. But those students who are regular to my classes, you will understand that first 2 to 3 questions in my class, they are easy. Slowly I will take you to the difficult questions. After some time we will only in the difficult questions. So please be with me till the end. You will understand many new techniques. Okay. So the answer to this question is 13 nanocoulomb. Option C is the correct answer. Now take just 10 seconds and try to give the answer for this. Fatafat. Every one of you, please be fast. Right? Not only fast, actually you should start thinking in the different way. Okay. How to use the common sense to solve the question. That is very, very important. And I like the students who apply the common sense more than the formulas and mathematics. Okay. Right. Sir, yes. Srivastava, definitely I will provide the PDF, but my suggestion is get contact with me in Telegram group. So the second question is, an energy source forces a constant current. Look at this, constant current of 2 ampere for 10 seconds. Very good. So 2 ampere current is constantly flowing for 10 seconds. So it gets accumulated, obviously, correct? So flow through a light bulb, 2.3 kilojoules is given off in the form of light and heat energy. Calculate the voltage drop across this. See, it is obvious choice, right? When we have a bulb, if you pass the current through the bulb, naturally because of the resistance of the bulb, heat energy will be dissipated. So the voltage will be dropped. But how do we approach this one? Because you already might be knowing that, every one of you might be knowing that the voltage can be systematically written as, or voltage drop can be written as how much amount of energy we have utilized to move unit amount of charge. This is a basic fundamental of. Krishna is very fast here. Very good, Krishna. Right. So dW by dQ, correct? So dW by dQ. But as the work is so heavy here, 2.3 kilojoules, damn high that is, correct? So therefore there is nothing to wrong, like, you need not to write like dW by dQ. You can even go for W by Q here, where W is considered clearly as the, in fact now it is better and wise to write instead of small q, you can use this as a big Q also, no problem, correct? What is the total amount of energy? 2.3 kilojoules. So 2.3 into 10 to the power of 3, of course, divided by what is the Q? Q is nothing but the total amount of current into time. Simple, correct? So therefore we can say 2.3 into 10 to the power of 3, of course, divided by what is the total amount of current? 2 ampere into 10 seconds here. So if you solve this, I guess you will going to get option B is the correct answer, because I have already solved it. Okay, 115 volt is the answer. So many students have given the answer because this is the easy question, trust me. Okay, but what you must understand is this formula. Clear? I want to cover this concept. Now, if I ask what is the power, then how can I write? Power could be always written as a rate of work or rate of energy, dW by dt, correct? So therefore we can write down dw by dt as dw by dq, of course, into dq by dt, correct? So dw by dq, every one of you should understand this as the voltage, into dq by dt can be written as power. So therefore power could be written as voltage into current. However, we don't require this at this point of time, we require only this. As I said, not only the question, I will also cover concept also. It's like a revision to many of you. Okay, now let's move on to the next question here. Now tell me, fatavat, every one of you, sir, how can I get the PDF of this solution? Simple, Aman, you just message me in Telegram group, I will going to send the PDF, easy, right? So let's go to the third question. Find the current I in the below circuit. Every one of you, right? Just take 10 seconds of time, I want the answer fast. Most of the times what happens is, whenever they see the question, they will think that which formula I should use here, or which technique I should use. Should I use source transformation? Should I use KVL? Should I use KCL? All this way. Don't look at in that way. Every question is different in circuit theory. You must go with the common sense. Okay, right? Common sense is the most powerful thing compared to mathematics, physics and chemistry. Will you agree with me or not? Everyone, 40 students are there in the live. All of you must tell me common sense is powerful than mathematics, physics, chemistry. Will you agree with me or not? Now, coming to this question, the best way to solve this question is simple way. So let's assume that this is grounded here, okay? Or else you are not interested to look it in this way. The best part is, whenever you might have studied that when a current source is connected in parallel with the resistance, this can be converted into voltage source in series with the resistance. I repeat once again, when a current source is connected in parallel with the resistance, that could be converted into a voltage source in series with the resistance, correct? So that means don't disturb the remaining circuit here. So remaining circuit, because I am going with the basic approach, okay? But later I will go very fast, so you should catch up this one. Now, as I promised that this is going to be 6 ohm resistance here. Now, this particular, whatever is there here, the current source in series parallel with the resistance, now we can convert that into voltage source in series with the resistance. But how do we convert into voltage source? Current into resistance. I repeat, current into resistance is a voltage. Very good. So therefore I can write down voltage here. How much is the voltage? Current is 4 ampere, resistance is 2 ohm. All put together, this is a 8 volt battery. But where should we write like plus and minus here? So the plus is actually at the tip of the current source, that means the direction of current source. So here it should be plus, other will be minus. So plus is the tip, direction of the current source, minus is the tail of the current source. Very good. And along with that, we need to keep a resistance here. This is going to be 2 ohm resistance, correct? And along with that, we do have still 8 ohm resistance according to the circuit diagram. And then this is connected straight away to another voltage source here, and that is 12 volt voltage source, correct? So this is the circuit. Now, why I have given this question is, I want to educate you that the voltage source formation is from the current source. So that means current source in parallel with the resistance can be converted to voltage source. Now after this, how to get the current? Because we have seen that they are asking the current that is flowing through the 8 ohm resistance. But successfully every one of you can see here very clearly, because it's not so difficult. Just give me 1 second, all of you. Yes, guys. So please explain the once the condition to apply the source transformation. Definitely, Krishna, I will explain. Just give me some time. Otherwise, I will put a question, and from question I will going to explain. Is it clear everything? Handwriting and audio, video quality, is it clear everything, or should I change the color? Please let me know so that I will understand. Okay. So current is actually traveled in this way, right? So, and this means because they are asking the current in this way, so obviously the current should come like this, right? And that current has to be supplied like this. Now you must think in this way. 16 volt is there in the left hand side and 12 volt is there in the right hand side. Quite logically, the current has to flow only in this direction. Most importantly, current entering terminal will be taken as plus, current leaving terminal will be taken as minus, correct? And again, current entering terminal will be plus here and minus here into the passive element. Resistance is a passive element, so current entering terminal in the passive element is plus, leaving terminal will be minus. Clear? So same here, plus and minus here, right? So now you may be asking a question to me, sir, why you have done this one? Very easy, because I want to apply KVL. How do we apply KVL? So you can start from any point here. So let me take another color here. Apply KVL in the loop. Apply KVL in the loop. So if any color is not visible, kindly let me know so that I will going to change this one. Clear? So when you start from here, the first thing that comes to my mind here is, so start from here. When you start like this, right, first go in this way. When you are traveling, you are getting the minus plate first. So when you are getting minus, so obviously this is going to be minus 16. Clear? That is a voltage drop. Then don't stop, continue here, continue. And when you continue, you are having the plus, right? So plus here, but this is a passive element, it consumes the power. So current into resistance, that is the voltage here. So I into 6, because that is the voltage drop, right? And then if you still continue like this, now you are getting minus of 8 volt. So therefore minus 8 here, because I am applying the KVL, Kirchhoff's voltage law. Following to that, again if you continue, you are having plus here. So therefore plus 2 times of I, right? Why? 2 is the resistance, I is the current flowing there, right? And then continue to the next element. In the next element we have positive here again. So therefore plus here 8 ohm resistance into current I here. And then when you come down here, obviously you got plus 12 here. So that would be equal to 0. Clear? There are a number of ways. So screen is not clear sometimes. Okay, Rufina, I will try to change, color. I understand that there might be a little bit blur here, but if it is so much problem, then let me know. Okay. So this must be equal to 0, right? So from here, how can I write? This is minus 16. Of course, this is plus 12. So if you take finally to that side, so what it will become? Minus 16, minus 8, minus 24, plus 12. So it is minus 12. So take that side, it will become 12. So therefore, 12 is on right hand side, and this side we have 6i, 2i, 8i and 8i. So all put together, this is going to be 16i, and I is equal to 12 divided by 16, and this is equal to 3 by 4, which is equal to 0.75 ampere. And I love the guys who have already done it, right? Increase the thickness of the color, sir. Okay, fine. So let me increase the thickness. Some of them have given a wonderful idea. Fine. I'll see all possibilities, right? So 0.75 ampere is the correct answer for this question. I hope you got the answer earlier to me, right? So we have covered 2 concepts here. One is the source transformation technique, and the second one is the KVL. Then you must ask this question, sir, how do you got the source transformation technique? First of all, whenever you kind of find, having this combo, because this is a voltage source in series with the resistors, this is also a voltage source in series with the resistors. So if I have a uniform pattern in the circuit, then it is very easy for me. So that made me to think in this way that yes, convert this into the voltage source, because the most challenging part in the circuit theory is which concept should be applied or which technique should be applied. That comes only with the practice. Clear? Otherwise, always start with the current and travel with the current, you will converge to the correct destination. Now let's move on to the next question here, right? So the statement of the next question is given like this: determine V0 and in the circuit shown in the figure. Clear? So now slowly I am increasing the standard of the question. It may take some time, but I sincerely request every one of you participate and do it. Okay? Right. So any one of you. So this is the question, and this question covers dependent voltage sources concept. Now you all can see we can apply KVL, because because V0 is the question. Now look at that. Where is the highest voltage source here? 12 volt is the highest voltage source, and they also mentioned clearly that current is traveling from 12 volt voltage source. So as I have already explained to you that current entering terminal is plus and leaving terminal is minus. Take that into the passive element. Again I am saying this one, passive element. So this current will all the way flow like this and flows like this, right? Again I am saying that current entering terminal is plus, leaving terminal is minus only in passive element, not in the sources. Okay? And when you continue like this, obviously the current will all the way travel like this. This they have given this, like what you call polarities. I have not taken this minus and plus, they have given this. Okay? Keep it like this. And then you all can see the current is completely making a loop in the closed loop circuit. Then obviously we can apply KVL here. See, so many students got different answers. So let me solve this one, right? So as you all can see, as it is the series connection, start from here and apply KVL here. So how do we apply the KVL now, right? So when we try to apply the KVL, you must be really very careful with these things, right? So yes, Now when we apply the KVL, I'm extremely sorry, yes. So start from here, and when you start from here, if you go in this way, first you are touching the negative loop here, I mean negative voltage source, minus 12 here. So I repeat here, apply KVL in the loop. Apply KVL in the loop. Right, minus 12 here. And then when we go like this, right? So you are touching the positive terminal of the load here. So 4 ohm resistance. So therefore 4 is the resistance into current I. Clear? Again, that is the voltage drop here, right? Some people are getting 48, some people are getting 24. Let us see who is correct. So 4 into I. And then when you go like this, right? So then you have a voltage source here. It is natural tendency of dependent voltage source to provide the voltage. What is the voltage of this source? Even though it is a dependent voltage source, it was clearly written that its voltage is 2V0. So therefore I will write here plus, because in KVL right now I am here and I am touching the positive plate. So therefore plus I am writing, and the voltage given by the dependent source is 2V0. I need not to think much about that. That was written there, 2V0. And if I still go ahead, so look at that, what is happening here. When I touch here again, minus 4 is there, isn't it? So minus 4, absolutely I can write like this. And then still continue here, don't drop here. So when you continue still here, come like this, right? When you come all the way like this, then you will be understanding minus V0 is there, because according to the direction which is given, minus you have touched here. So minus V0 I will write here, all the way you come here up to here, so finished. The loop is over now, right? So it is 0. So now again we all can see 4 times of I and plus V0 I can say that is equal to 16, because minus 4 is there, minus 12 is there, that will come all the way 16 here. So now V0 has to be changed. Look at what is V0 here. So it is mentioned like V0 here, but the current direction is actually coming from this way, right? So you are taking plus here and minus here. Now I would like ask a simple question, because you all have a common sense here, right? So earlier what we have discussed, we have clearly discussed that the current entering terminal should be actually positive, leaving terminal must be negative. But what he is saying, he is already taken in the reverse way, correct? Plus here and minus here. Then what will going to happen? If you start looking from this side, right? If you go in this way, so V0 can be written as you are taking the voltage drop opposite to the direction of current, naturally you have to indicate minus, because your selection of voltage here is opposite to the direction of current. Therefore, I should say V0 is equal to minus 6 times of I. Clear? Simple. So V0 is equal to minus 6 times of I. Then what should I say here? 4 into wherever I is there, that I should write down now as minus V0 divided by 6 here. And of course plus V0 is equal to 16. Don't drop in between anywhere. So this is going to be minus 2 by 3 times of V0 plus V0 all the way, that is equal to 16. Right? So what is this one? 1 by 3 V0, right? So anything anywhere got wrong here? 1 by 3 times of V0, that is equal to 16 here. Correct? Yes. So now what would be the final answer here? So V0 is equal to now 48 volt. Clear? 48 volt is the correct answer. Many students have done, but Rufina has made the wrong answer. Why? The problem is in the polarity here. Many students, they commit the mistake. They have given that plus here, minus here. So you have to strict with the question. Yes, if I go like this, plus here and minus here, if I travel from left to right, it should be considered as V0. But as it is opposite to the direction of current, when we are writing the voltage drop, we must take minus here. Clear? So is it clear to all of you? Yes, very good, Kaushika. What is the final answer? Minus 48 or 48? Every one of you must answer here. Fatafat. Comment box is running like anything. So Kaushika, Rashekar, Amar, Aman, Rufina, Chapa, Vinod, Krishna. Krishna is giving very fast answer. I like him, right? 48 is the correct answer, but many students have gone with the minus 48. Please try to understand. If you have doubt, once again revise the or rewind this, you will understand. Clear? So current entering terminal is PA. That is fine. I too agree with that. But they have taken this as a reverse, right? So that's why we got this value. According to the direction what they have taken, your answer is 48 volt. Clear? So now, yes, Rufina, correct. Now you are on the track. Now, Fatapat, tell me this question answer. Right, next fast, every one of you. So I think I am doing slow, you guys are really fast. Okay, find voltage and current in the circuit shown in the figure dash. Right, every one of you, 45 members are there in the live, every one of you should try to solve this. I don't mind whether you are going to share or not, but I want you to enjoy the session and get good marks out of it. Okay, right, make it fast. Find the voltage and current in the circuit shown in the figure. Now what is the best choice? Whenever you will see this question, most of the students, they will try to apply source transformation, or they will apply different things. But common sense, very important thing is common sense. What is the question? Find the voltage, correct? Mohan Sai, you were saying earlier that you are unable to understand which technique you need to apply. Now think logically. You require to find the voltage across 4 volts, right? So can I say it like this? V0 is equal to, it's very easy. V0 is the voltage drop across 4 ohm resistors, and current is entering here, and entering terminal itself it is given plus, and leaving terminal is given like minus. No problem with that. Very happy. Correct only. So V0 is equal to, resistance value is 4, current value is I0. So that means you can get the voltage if you find the value of the current first. Correct? So if you know how to get the current, then you can find the voltage. That is the meaning of this. So what is the question actually? Question is find I0, not voltage, right? So therefore, how do we find this I0? Again, don't be hurry-burry. Try to logically think from where this current is coming. 2 sources are there. One is independent source. This is having 3 ampere current. This is the direction of this current, 3 ampere, 3 ampere, 3 ampere. So 3 ampere will come up to here. Simple, right? And here, this might be a current dependent source. It is a dependent source, but it is a current source. How much current it is giving? 0.5 times of I0. Why it is giving current as the output? Because it is a current source, correct? So the current delivered by this will be 0.5 times of I0. Good. So let us say the current, whatever is coming up to here, that is going to be 0.5 times of I0. Now everyone must understand one important fact here, that so one current is coming like this and another current is coming like this. Both of them are mixing at this point and then they are traveling like this. Clear? So now you should apply KCL at this point. Correct? So apply KCL. I don't call this as a KCL, but I call this as common sense. Okay? Apply KCL at point A or node A. Right? So what does it mean? Sum of algebraic sum of all the currents equal to 0, or sum of the total current coming in must be equal to sum of the total current going out. What is the total current coming into the point A0? 0.5 I0 plus 3. Correct? So this is entering to the node. This is also entering to the node. Correct? So 0.5 I0 plus 3, that must be equal to the total current that is leaving. So that is I0 here. So easy here. So therefore I can say 2.5 times of I0, that would be equal to 3 here. So what is I0 here? I0 is equal to 30 divided by 25. Correct? So I must say this is going to be 6 by 5 here. So if it is 6 by 5, anyone got the answer here, right? 24. Did I done the mistake anywhere? Right? Oh, sorry. Extremely sorry, guys. A calculation mistake. हो सकता है अभी this is 0.5 and I am very sorry. Right? So you guys are smart. 0.5 I0 here, that is equal to 3. So therefore I0 is equal to 3 divided by 0.5 and that will come to 6 here. So then I can say 4 into 6 here, that would be equal to 24 volt here. So what is the concept you have learned here? So two concepts we have learned. One is current dependent source or dependent current source will generate current as an output. Clear? And we have also discussed about the KCL. That is, this current and that current both should be added at A such that the voltage will be dropped across 4 ohm resistance. Right? Now, Krishna Sir calculation. yes, thank you very much. Right? So, right. Sir, how do you find dependent current and independent current source? Simple, Ramesh. If it is mentioned like this with a circle, then this is considered as an independent source. Suppose if it is mentioned as like this rhombus symbol, then it means that this is independent source. I repeat here, this is the dependent source and I call this as an independent source here. Clear? Independent source means the current delivered by this will depend on, I'm extremely sorry, I have reversed it, just 1 second. Right. So this is going to be independent source and this is going to be dependent source. Dependent source means its current or the current delivered by this will depend on some other thing. Clear? So Krishna, right? Yes. TDV Krishna. Here we don't apply source transformation, sir. Not required. See, you must apply the technique when you can't solve with the basic. But most of the time you will going to get with the basics only. Correct? But if you want to apply, you can apply. But you should apply to this. That is resistance in parallel with the voltage, current source. That can be converted. No problem. And Krishna, you asked one more time earlier. Correctly said. Thank you very much. Right? Krishna, you asked this question. No? So what is the limitation for source transformation technique? Source transformation technique we won't apply for ideal sources. Okay, ideal source means, so practical current source will going to have a resistance, like finite resistance, but ideal current source will going to have infinite resistance. At that time you cannot multiply infinite resistance with the current and say that I have infinite voltage. Correct? So therefore if the resistance is infinite here, you cannot convert this to the source transformation. This means practical sources we cannot apply source transformation. Clear? Krishna, I have cleared your doubt. Very good. 55 students are there. Nice, right? So now come to the next question here. So consider the circuit shown in the figure. The current flowing through the 7 ohm resistor between P and Q is dash. Now I can tell you, those students, I took 1 minute to solve this question for the very first time. Now I would like to see how many of you can solve this question very fast. Krishna, have you got my explanation about dependent and independent sources? What would be the correct answer for this question? Now I am really excited to see how many of you will going to answer correct answer. First of all, see where is 7 ohm resistance. 7 ohm resistance is here and you require to find out the current exactly through the 7 ohm resistance. By the time when they see this question, most of the students, they feel that, oh my god, what is this nonsense? It looks zigzag here and there. How to solve this one? Correct? Right? So how to solve this one? Again, I am saying that this kind of questions, especially which were asked in the GATE previous papers, you cannot really answer if you follow mathematical formulas alone. You must apply your common sense. Okay? How do we apply the common sense? So they themselves have told that this is P and this is Q, right? Then you must take this as R here and S. So there are 4 nodes here. Agree? 4 nodes are there. Then you may ask a question, what is this, sir? We are able to understand easily. If I am a student, I am not so fast, but I am logical. So I'll start like this. Okay? I'll start. I am not in hurry, because for me accuracy is very important by protecting the time. Okay? Right. Sir, please tell the difference between practical and ideal. Right. So yeah, after this question I will tell you, Upendra, don't worry. First let me complete this because I am in the middle of the question. Right, this is one and this is another one, correct? And then this is resistance here and even we do have a resistance here, correct? So this is 3 ohm resistance and 2 ohm resistance. Kya ho gaya? Nobody has given the answer. I am really disappointed, guys. Make it fast. Krishna, where are you? Will you teach analog electronics in vision batch, sir? Kim Johan, that depends on the demand, right? Okay. So thank you very much. But anyway, we have great teachers. They will going to take analog electronics in app. We have Sanjay Rathi sir, India's best teacher. He will help you. And if time permits, I will going to handle the vision batch. Right. So let us focus on this first. So now you must understand that. So P and Q is there, right? So try to fix these points here first of all. Okay, so here R is there here and S is there here and we have P, of course we have Q here, correct? So no one has given the answer, 0.5. Upendra is giving some answer, we'll see. Right, so P and Q, fine. Now 5 ampere current is there. So where is that? So that's why I told you that now 5 ampere current source is there between R and Q. That is the catch, correct? So if it is R, then obviously this is also going to be R and this is also going to be Q. That means current source direction is from Q to R. This is the way how you need to distinguish the question. See, you don't require rocket science for this. Only common sense is required. Clear? 5 ampere question, right? So Tirumalai, as of now, we don't have any special course for ISRO scientist program. I think last time also you have asked the same question, and last time also I have given the same answer. Again, I would like to say the same thing, right? So this is the way how it is, right? Because between R and S we have a short line like this. Kya ho gaya bhaiya? No one has given the answer. Amar is saying 0.9, Krishna is saying 0.5. Let's see. So now it is shorted like this. Most of the students, they will come up to here. But kya kar sakta hai after this? What is the way you can use your brain after this? See, as I said, always think like a very plain mind. Okay, with a plain mind. This is R and this is S. Now this short circuit line is saying that R and S both are connected and there is no voltage drop between R and S. What does it mean? If it is R, then I can simply say that this is also R, isn't it? So this can also be called as R only. That is the meaning of short line here. This is also R here. So if it is R and R, then look at that 3 ohm resistance is connected between P and R, correct? And this 6 ohm resistance is also connected between P and R. What does it mean? 6 ohm resistance and 3 ohm resistance both are connected in parallel across P and R, correct? That's the catch what you need to do. So therefore, there is nothing required for me. I need not to write this 6 ohm separately here. Anyway, it is connected between R and P. So I will remove this and straight away use a simple line here and rewrite this as, like this here. Clear? So that's possible here. So this is 6 ohm resistance now. That is the way you should think. Acha hai na ye question. So everybody should say whether you love this question or not, right? And then this is R we have said, right? So this 2 ohm resistance is between Q and R, and even this 2 ohm resistance is also between Q and R, correct? What does it mean? It means that you don't require to write again this separately here. Rather, it is better to write this question here. So every one of you should say, have you liked this question or not, right? So 2 ohm here. Now you must say that, or now you have to understand this one. This 2 ohm and 2 ohm both are actually in parallel, correct? So therefore, now I have R here and P here. So look at the beauty of this question. Q here, correct? Between R and Q, 2 ohm and 2 ohm both are in parallel. So if two resistors are in parallel, what is the combination? Equivalent combination. R1 R2 by R1 plus R2. That means 2 into 2 divided by 2 plus 2. That will become 1 ohm, right? So this is simply like 1 ohm. Now what is there between P and Q? P and Q is the required one actually. P and Q, we have 7 ohm resistance here, right? So therefore 7 ohm resistance is there. I is the current here. No issue here up to here. And then 6 ohm and 3 ohm both are connected in parallel between P and R. So therefore how can I write this one? P and R, 6 and 3 both are connected in parallel. So equivalent combination is how much? 6 into 3 plus 6 plus 3, right? So it is 18 divided by 9. So obviously I can say this is 2 ohm here. Clear? Now additional to that we have a driving force here, 5 ampere. So let me write down this as a 5 ampere current here. So if anyone got the answer, fine. Otherwise you please try to see here. Now the best option, again you must understand that yes, I need to use voltage division rule here because P and Q are here through the 7 ohm resistance, and as it is looking like somewhat zigzag manner, 5 ampere in parallel with 1 ohm resistor. As I said earlier, this can be written simply as a voltage source here. How much voltage source here? So look at that. It's a 5 volt voltage source here with 1 ohm resistance. So this is 5 volt voltage source with 1 ohm resistance here. Clear? Now tell me what is the current value here, because you all know that the current I is here. From where it has to come? It has to come all the way like this only. There is no other path for the current here. That means this current has to come from this voltage source only. This is I, right? And this current all the way circulates like this in the loop and like this. So that means it is a loop, right? It is a clear loop. Now how can I say the current here now? Now the current in the loop can be given as the total supply voltage is 5 volt to the loop now. In the loop we have only single voltage source, that is 5 volt. And what is the total amount of the load now? Total amount of the load all put together 1 ohm, 2 ohm, 7 ohm. So 1 plus 2 plus 7, all the way it is going to be 10 ohm resistance. So 0.5 ampere is the correct answer. So nice, out of 55 students, 6 students have given the answer, and tell me whether this is good question or not. I feel that this is a reasonably good question because you need to think little bit. Okay, so that's why I told you that slowly we will move forward. Okay, slowly the standard of questions will be increased. I am sure by the end of all 4 lectures in circuit theory, we will reach the peak. Okay, so yes, very nice. Thank you very much, Krishna. Right. So I is equal to 0.5 ampere. That's the solution for this question. Now let's move on to the next question. But everyone should answer this. Rufina, yes, very good, very good. Deduction of networks. Yes, fine. Right, good. Now this is the next question. Don't look at that what is the VTH and all this. Just try to understand the question first. In the circuit shown below, the voltage VTH. Instead of VTH, let us call this as a V0 because some of you might not heard about this VTH, but let us fix as we are in basics right now. That is V0. How do we evaluate this? So this question, before answering, now you should tell me, so sir, why don't we apply current division when they are in the triangle, sir? Yes. So where is the triangle here? So this is not in the triangle actually. See, you can apply current division when the resistors are in parallel. The problem is this 5 ampere. If you see 5 ampere here, this side resistance is different all put together and this equivalent is different. So it will not be so easy for everyone to understand that, but you can apply current division also. Okay, if you get that, that's very, very clear. Blurred image, right? Right. So one second, I will do one thing, one small favor to you, right? Now this may be a little bit blur. Yes, I guess now it's okay. For this question, we will go with this. Okay, this light is set up. There's a small issue here with the lighting, but please try to adjust. Tomorrow I will going to change and rectify that. Okay, so in the circuit shown below, the voltage V0 is going to be dash. Rufina, now tell me, is everything is fine? Right. So here we have 1 ampere current source and 1 ohm resistance here. Now the first thing what you should get is, as the current source and resistance both are in parallel, it's always better to have voltage sources if possible all together in the entire loop. Otherwise only current sources, so that uniformity will always give easy analysis. Clear? Right. Now this 1 ampere current source, 1 ohm resistance. First, fatapat convert this one first. So this is going to be, what is this? No one has given the answer. I want the answer fast, every one of you. Right? So you guys have already done these things, right? Circuit theory classes in vision. 1 ohm resistor and plus here and minus here. So what is the voltage source? 1 into 1. So it is going to be 1 volt. Correct? This is easy. And then you can see here minus plus 2 volt voltage source is there. Along with that 2 ohm resistance is also there. And then again you can convert this into voltage source and current source. This can be converted. Absolutely, this can be converted without second thought, right? 2 ampere in parallel with 2 ohm, that will be a 4 volt here. So let me write down 4 volt here first of all. And then resistance is 2 ohm resistance, no issue. Up to here, my students can do these things, right? And then 4 ohm resistance is there, correct? And then you require to get the voltage V0 here. Now all of you please stop solving and see here. Every one of you stop solving and first see here. See, previously some of the students, they are asking what is the difference between ideal sources and practical sources. Some of the students, they are asking what are the drawbacks of source transformation technique. My suggestion is, in BYJU'S Exam Prep app, in BEP app, you can find my recorded lectures of circuit theory. There I have explained each and every topic clearly. Voltage sources, separate lecture. Current sources, separate lecture. Ideal sources, separate lecture. Practical sources, separate lecture. So you can go through all the lectures and I am very sure you will not get any doubt after that. If you get any doubt, you can directly message to me. This is my number, and whatever the support you require, you can directly message me. Okay, no problem. Now come to this point here, right? So why different students are getting different answers here? So whenever you get this, my suggestion is think logically first. Okay, so we are very clear that this is the open circuit here. If it is an open circuit, what would be the current here in this line? There is no current here, 0 ampere. Correct? So stop, everyone stop writing, stop solving, please see this side. So if it is 0 ampere, 4 ohm current resistance means, what is the voltage drop? There is no voltage drop here, that is 0 volt. Why there is no voltage drop? The reason is there is no current there. If there is no current through the resistor, how the voltage will be dropped? So the voltage will be 0. If it is 0, then I can say V0 is directly, because that branch doesn't have any significance there now, right? Because there is no voltage drop, means you can straight away remove this thing, right? So this is the fundamental step you need to understand first, right? So most of the students, they do mistake here. That's it. This is V0. You can remove that one, right? Now the next immediate step what we should do is, here we have 1 volt and here we have 4 volt and here we have 2 volt. So don't know what is the direction of current. So what would be the best option now, right? The best option is blindly apply the KVL, right? Start from here and apply the KVL. How do we apply the KVL? Start from here. So let us assume that you are traveling in this way. Assume that any direction current, okay? Assume that this is the direction of current and current is going like this, current is going like this, for example, and this is the way how I am assuming the current. Because I don't know the current, but I need to understand one thing, that you need to understand that the current is circulating in the loop, correct? So therefore, if as we have started from here, if you apply KVL, first -1 will come. So minus negative plate and then plus here, minus here, current entering terminal in the passive element, that is 1 ohm resistance, is positive, leaving terminal is minus. So this would be plus here, 1 into I, that means current into resistance, 1 into I, and then again minus 2 volt here, and again plus 2 times of I here, because you will be having plus here and minus here. And as you are going in the loop like this, next you will be having 2 ohm resistance. What is that? 2 into I here, fine. And then positive voltage here, so plus 4 here, all put together, this is 0 here, correct? So easy calculation here. What is this? 2I, 2I and I. So totally it is going to be 5 times of I, clear? And -1 and -2 and plus 4. So what is that? Plus 1. So I can say 5 times of I plus 1, that must be equal to 0. Therefore I is equal to -1 by 5, which is equal to -0.2 ampere here. Clear? So after this much of hard work, what we understood here is the current is -0.2 ampere here, correct? So current -0.2 ampere means what? It means that the direction of current what you have taken is actually reverse to the original current, clear? So this means that you must understand here clearly, this would not be the current direction, right? So let me change this one, right? Or else even if you take in the same current direction, no problem, but you need to use that, yes, it is -0.2, that's it. Now this is your V0, plus is here, here is minus here. Now take that way only. So plus V0 is this one here, so V0, and here minus here. So what should I say? V0 minus 0 here. So I say this is the ground here. So therefore I can say V0 minus 0 volt, that is this node voltage minus this, that is considered clearly as the potential difference here, correct? So V0 minus 0, that would be equal to, what is there here? 2 times of I here. So 2 times of I, let me write down, that is the voltage drop in this branch here from here to here, and then you have plus 4 volt. So therefore 2I plus 4, clear? So yes, 2I plus 4. Then what should I say here? V0 is equal to 2I plus 4. Very nice. But what is 2 times of I here? Because I am absolutely going with the direction of current what I have assumed, and when you taken this current, you got -0.2, so you should use that one now, right? So therefore 2 into -0.2 plus 4, obviously V0 will going to become like 3.6 volt. Clear? 3.6 volt is the correct answer for this question. I have seen several messages top to bottom 3.5, 3.6. I hope you guys have done better. So this is another question where you can apply this, and now you start thinking in the different way. Is there any other possible way to solve this question? Definitely I will come back to this, but anyway I suggest you this question you can solve easily only like this, okay? Most of you might have solved in the same way. Now let us go to the next question. I love this question. Now let me see how many of you will answer. See, every time after 1 or 2 questions you will get a good question, okay? So for the circuit shown in the figure, the current I is dash. Fatapat everyone. Sir, can we apply nodal? Yes, Hema, you can apply nodal. Nodal is always you can apply. KCL, nodal, every time you can apply, and most of the time your questions will be solved easily only with the nodal. Clear? So this is one of the good question. Try to answer this. I will give 2 minutes of time. I will also explain easiest way. Now many of you might be thinking that should I apply source transformation, or should I apply KCL, should I apply current division, should I apply voltage division? What? Answer is you should apply common sense. Okay, try to answer. So Krishna has given already as 8 amperes. Let us see. Are you guys enjoying with this lecture? First of all, so first you can keep this as a P and this as a Q here. This is a Q, this is also Q, and you must understand this is also Q, this is also Q here. Clear? Are you guys enjoying with the lectures or not? I want your reply, because your reply will give energy to me. If I get energy, I will go to the exciting state and I will give my best. Okay, so P and Q, of course this is the voltage source, right? Yes sir, right. So this question, many of the students, they will going to make nonsense here. So first thing what you can do is mark these nodes, then half of the problem it will be solved. I am saying half of the problem. Why it is? Because you see this is also P here, correct? And let us mark this as R here. Clear? So now you must immediately understand one thing, that this 4R resistance, where it is between R and Q only, correct? So therefore what I do is, let us take like this here, this is Q here, all the way this is Q only up to here. Let us make this as a Q, undoubtedly, correct? So you must understand 4R is there between R and Q. R I don't know where it is, so let us keep R here. So for example, R is here, right? So R is here. So first you must understand there are 3 resistors here, 1, 2 and even third one also, right? One second. Yes, there are 3 resistors here. So first of all, to R, from R to Q we have 2R, we have 4R, we have even this 4R also, correct? R to Q. So that means if it is R, I can say confidently that this is Q here. There are 3 resistors here. Very first thing is here, one resistor here, second resistor here, and third resistor here. Clear? So what are these resistors? 2R, 4R and 4R. 2R, 4R and then 4R. Write down like this. And R anyway connected to where? R is connected, no, R is not connected to Q directly. So this is the way it is connected. Just give me 1 second. Right, this is the simplest way, correct? Now look at that, R is connected to P with a 3R, correct? So then immediately what we can do is, P is here and connected to R via like this. Clear? So this is going to be 3R, first thing, correct? So don't be hustle puzzle and make nonsense here. Just wait for some time. Now you can all see here very clearly it was written that, so there are 2 resistors here, 1 and 2, and what was there here? 2 times of R, and here 4 times of R is there, and of course this is the current I here. Clear? Now here you need to apply. Very good session, sir. Thank you very much. Thank you very much to every one of you, right? So now we are having the current here. Excellent, no problem. Here you should apply your common sense. Why I am asking common sense is, if you don't apply common sense and do some nonsense here, you will going to get a different answers here. Great. So you all know that the current flowing through 2R resistance is I. Then what is the current that is flowing through 4R? What is the current flowing through the 4R? Because we all know that if the resistance is more, the current value is less, correct? If the resistance is more, current value is less. So here 2R to 4R, what does it mean? Twice the resistance. If the resistance is twice, then the current will become half, correct? Current will become half. That means without any second thought I can say the current here is I by 2. This is the logical way you should think, right? And most importantly, they are saying that in 4R they are having 1 ampere current. Look at that. So in 4R they are having 1 ampere current now here. Clear? Okay, no problem. 4 ampere for 4R they are having 1 ampere current here. Then what is the current in this also? Because that is 4R, it is connected between P and Q. So the voltage remains same for this 4R and this 4R. Naturally the current should be same. This is also 1 ampere. Correct? So and then here we have 2R. Means half of the resistance of 4R. 4R is big, 2R is less. Correct? So how much current will be there here? So twice the current that is flowing in 4R, 2 ampere here. Correct? So right, very good. So 2 ampere here, 1 ampere here, 1 ampere here. So what would be the answer now? The answer for this I would like to say here 2 plus 1 all put together. This is how much? 4 ampere here, right? So 4 ampere is the current that is flowing in 3R balance here. 4 ampere is the current. Then only it is possible, no? If it is 4 ampere current, out of 4 ampere, 2 ampere is going this side, 1 ampere is going this side, 1 ampere is going this side. So 2 plus 1, 4, that has to come all the way from 3R. So after this much of hard work, what I should conclude here is, right? Now I can remove all the things successfully here, and only one that is required here is, look at that. Look at the beautiful question this is, right? All put together, only one information that is required is 4 ampere current is coming here. Fine, no problem. But can I combine these things? It is very easy for me. 4R in 4R, parallel combination is how much? The parallel combination of this is 2R, correct? And the parallel combination of 2R and again 2R, how much that is? That is R, correct? So that means everyone who has the common sense, they can understand that combination, parallel combination of 2R, 4R, 4R, all the way it is going to be equal to simply like R. Clear? Nothing else is there apart from R here. So I am writing this as R here. Clear? So R would be the resistance here. But you must understand that if it is 4 ampere current, the same 4 ampere will go to this equivalent of R. No issue. Correct? So yes. So this 3R plus R. What is this? 4R here. Correct? So therefore what should I say? So I can say this, all remove this and make it as a 4R here. So the good thing is I can say all put together this is going to be 4R here, right? And interestingly we know what is the current that is flowing here, that is 4 ampere here. Clear? 4 ampere here, right? So now look at the beauty of this. In 4R the current flowing is 4 ampere. This is also 4R, but both of these two are between P and Q. Voltage is same. Then the resistance is also same here. So whatever the current that is flowing here, same current should flow here. Correct? Because both are connected in parallel means voltage should be same. So therefore I should say here that I by 2 and 4 ampere both must be same. So if you take out this, then I will be equal to 8 ampere current. Clear? So that is the answer for this question. Now tell me, is this is good question or not? I am very happy to see that there is no downfall. 55 is constant here, right? Okay, very good. 8 ampere is correct answer, right? See, what you must understand is there is a chance that some of you might have solved easy way, but every time from the teacher you should not only get the concept, you should also get way of approach, thinking, right? Now I have not used any formulas. I just have seen, okay, here the resistance is twice than here, so the current will become half. Here the resistance is more, here the current is so less. So I just went with a very common approach, right? Common sense. That is why I need, wonderful question. Yes, that's why I am saying that you have to put your brain, common sense is more important. Current ज़्यादा हो गए so resistance is कम हो, so obviously current will be more there. Correct? So now let's go to the next question. I think this question easily you will do it. Okay, but anyway, as a matter of discussion, I need to discuss this, but let me discuss first. The equivalent resistance between A and B is dash. Where is A? Here. A is here and B is here. So this question I am very sure most of you will do. Yes, like the session guys. Okay, great. Right. So anyway, I'm like a teacher that I generally don't ask anyone to like or share. If you like it. Otherwise, you can also comment that yes, you have not followed well. No problem. I am ready to take anything. Okay, right. So the equivalent resistance between the A and B is dash 1 ohm. How do we get that one? Simple way, right? So I'll tell you. Most of the time, it is a puzzle for the students whether the resistances are connected in series or parallel. Simple way is, if you drop the current here, let us say the current is dropped here. If you drop the current, all the way the current will come up to here. No other path, it has to go in the same way. Again, it has to go in the same way. It will come up to here. Correct or not? Right. So if the current is traveling in this way, if the current traveling through two successive branches, I mean like loads is same, then I can say both of they are connected in series. Clear? So that means 1 ohm and 1 ohm both are connected in series, and you don't really require the rocket science to understand that, right? So 1 ohm plus 1 ohm, I can say this is 2 ohm all the way, correct? So let me take it here, 1 ohm plus 1 ohm all the way, this is going to be 2 ohm here. So let me take 2 ohm here, correct? So it means that now very calculatively I can say, forget about all these things, and it is just a 2 ohm resistance in parallel like this. Simple. 2 ohm resistance in parallel like this, because 1 plus 1 it will become 2. So the 2 is in parallel with 6. Now 2 in parallel with 6, what it will going to become? So it's simple, 6 into 2, R1 R2 by R1 plus R2, correct? So this is 12 divided by 8. I am very sure that it will going to become like a 3 by 2, right? So 3 fourths and 2 fourths, right? 3 by 2 here. So therefore you will be having a straightforwardly like this. So here we have A, and here we do have B here, correct? So it is going to be B. So what is there? Of course some zigzag mechanism is there here, okay? So but let me take it up here, right? So give me 1 second. Yes, so here 3 ohm resistance is there, correct? And then P and Q, most important thing is P and Q, don't forget that one. Between P and Q we have 3 by 2. So let me take 3 divided by 2, right? So that's all. Fine, but you have to understand this clearly, that between this, if I say this is R and this is S, here the real drama is there. So please see here. So between P and Q, sorry, this R and P, we have 2 ohm resistance here, correct? And we can bring this Q to this side and S to there, no problem, right? Then I can say, let me call this as a S here for time being. If we shift this Q to this side, what will going to happen? Yes, right? So because 3 ohm is connected between S and P, right? So 3 ohm must be connected like this. Very happy. S to P and R to Q via this, right? So what we can do here? So we can actually interchange this and make it this calculation, right? Oh, already everybody got 3 ohms. Then you might have informed me, right? So just if you go with the series and parallel combination, because I will going to discuss more good questions compared to this, because everyone has answered this, right? Everyone is answered. Answer is 3 ohm, absolutely correct, that is correct. So here you can directly go with the parallel and series combination. This is very easy because I feel that everybody is able to solve. Then let us not waste the time here. Okay, let's go to the next question directly. And this question, why I have included here is, this question was asked in the previous year GATE paper. Okay, so yes, okay, that question is easy. Let's go to the next difficult questions. Okay, so this is also not difficult question, but I would like to explain, the star to delta conversion concept should be covered. That's why let me use this question to cover that, right? So the first thing is, we have delta here. So what should be the best thing? Because you need to cover between A and B here. What is the R equivalent between A and B here? Any one of you? R equivalent. So first thing is, every resistance is 1 ohm. So every resistance is 1 ohm. Now we have star to delta here. So let me call this as RA, and this is B here, and this is C here. So it is better to convert this into, star here like this. Clear? Let us call this as a R1 here, and let us call this as a R2 here, and let us call this as a R3. Then tell me what is R1 and R2 and R3. So first R1 would be equal to, simple, you require to convert delta to star. Clear? Delta to star here. How do we do that? Delta to star means, guys, delta to star means what we will do here? Make it fast, every one of you. Right, 1 2 3 4 5 6, yes. Right, so any one of you, correct? So the first thing is, this R1 could be written as this resistance into this resistance divided by the total resistance. So that is RA RB, we can say, whole divided by RA plus RB plus RC. Clear? So as every resistance is 1 ohm, so it is something like R1 would be equal to 1 into 1 divided by 1 plus 1 plus 1. So it is equal to 1 divided by 3 ohm. Simple. Very simple. Correct? So that means R1 is 1 by 3. Now if you see, every resistance is 1 ohm means, the way how you calculated for R1, you will use the same calculation for R2 and R3 also. Right? But when you are calculating R2, you will multiply RB and RC, divide with RA plus RB plus RC. That is the way how we will convert the star to delta here. Sorry, delta to star. So therefore I am writing directly here, R1 must be equal to R2 and that must be equal to R3. Clear? So then what will going to change now, right? So let me take here 2 steps here, because some students may get little bit doubt here. So A is there, of course here B is also there here, right? And between A and B there is a solid resistance like this here, and of course that is 1 ohm resistance. And then you have to understand very clearly here, so there is one big resistance here and there is one more resistance here. Clear? Everything is R only here, right? And now you have to understand clearly that, look at this, look at the beauty of this one. This resistance and R1, now they will be in series. Why? Because RA, this resistance and this are not there now. It's a star connection, right? So 1 ohm plus R1. So this all the way you will going to have 1 plus 1 by 3, that is going to be how much? 1 plus 1 by 3. So that is 4 by 3 ohm resistance here, 4 by 3. And here also you will be having 4 by 3 here. And here also you will be having 4 by 3 resistance here. Clear? 4 by 3 R here, and this is R here, of course this is R, and this is also R, and this is also R, this is also R. And you require to calculate between A and B. Sir, by perpendicular symmetry it is easy, sir. Yes, correct. I will explain after this, but let the students try first of all. Okay, so now 4 by 3, everywhere you are having 4 by 3. And now you must actually try to understand one important fact here, that again it is possible for you to convert this delta network into, star network into delta. Now convert star to delta then. Okay, star to delta. Clear? Krishna, my intention in this question is, every time we can actually do calculation with multiple approaches. Okay, multiple approaches we can follow, but the best part is I want to explain star to delta. That's why I'm using that here. Okay, star to delta conversion. When you are doing star to delta conversion, this is the star proportion here. So if I say this is A here and this is B here and this is C node, right? So what we should do here? First of all, so this can be converted now. Look at the beauty of this. Yes. Let me take another color. Right. So this could be converted now, a single resistance here and another resistance here, right? Another resistance here. Clear? So now let me call this as a R1 here, RA here, and let me call this as a RB here, and let me call this as a RC here. Now what is RA here? RA is the one which we need to calculate now. So that means this resistor we need to get from the star here. How do we get this one? This is so simple. This plus this, okay, 4 by 3 into R, right? 4 by 3 R plus 4 by 3 R, right? R we can remove that because R is 1 ohm resistance, so we don't require to write this. So if we directly go with this, 4 by 3 plus 4 by 3 again, right? So 4 by 3 plus 4 by 3, then product of these two, that is 4 by 3 into 4 by 3, 4 by 3 into 4 by 3, and divided by the opposite resistance, that is 4 by 3. Opposite to whom? RA, correct? Opposite to RA. So that is going to be 4 by 3 here. So this will going to get cancelled. So we have 3 times. So RA would be equal to 3 times of 4 by 3 here. So obviously this is equal to 4 ohm. And the similar calculations will go for everything. Similar calculations will go for not only RA, RB and RC. What about other guys? Kaushika, where are you? And you know, Rufina. Yes, Rufina is very much in line. So RA, RB, RC. Now I can say everything is same here, RA, RB, RC. Therefore, what can I say here now? So look at the other side of the coin now. Now we can remove all these things here, and we have 4 ohms everywhere here, right? So look at, right? So now we can remove this clearly and remove this and remove this here, and I will do one thing. So let us make clearly here. 1 second. This is 1 ohm and this is 4 ohm, and this is 1 ohm and this is 4 ohm, and this is 1 ohm and this is 4 ohm. Now everything is easy. 1 and 4 both are in parallel, 1 and 4 both are in parallel. So this combination will become 1 into 4 divided by 1 plus 4. What is this? 4 by 5 here. Simple, correct? So that is 4 by 5 is the resistance here, and this is also 4 by 5 ohm resistance. Therefore, what can I say here? Now remove all this stuff here, because ultimately you must remember the question properly. You require to calculate the R equivalent between A and B here, correct? R equivalent between A and B here. Therefore, what should I say here? Now the best option is remove this nonsense here, remove this nonsense here, and 4 by 4 and 4 by 5, correct? So you can write down this all the way as 4 by 5 here, and here also you can write down this as a 4 by 5 ohm, 4 by 5 ohm and 4 by 5 ohm. But now you must understand, if you drop the current here, what will going to happen? Suppose drop any amount of current, no problem. That will all the way go like this, all the way go like this. It comes like this because there is no other scope, right? So that means this is a loop now, right? 4 by 5, 4 by 5, both will be in series. So that means 2 times it will be there. So therefore I can remove all this stuff now and simply put this 2 times of 4 by 5 means it is going to be 8 by 5, correct? So that means all put together, this is 8 by 5 ohm resistance. Clear? This is 8 by 5 ohm resistance, right? Sir, doing ST in the long back question, getting wrong answer, sir. Where it is, let us see what will going to happen. Don't worry. So 1 ohm, 4 ohm, 4 into 1 by 4 plus 1, again 4 by 5 here. So let me take here. So it is going to be, now remove this one, and here we can say this as a 4 by 5 ohm resistance. Clear? Now easy. R equivalent is going to be this and this, both are parallel combination. So R equivalent could be written as 4 by 5 into 8 by 5 whole divided by 4 by 5 plus 8 by 5. That is R1 R2 by R1 plus R2. Simple. Calculate this, you will going to get the answer. Whatever the answer you get, that is the final answer. Guys, now you tell me it is already 10:20. We are ahead of 10 minutes. So can I solve one more question? Okay, right? So that I think this figure is a little bit blurred. So please let me know, is it clear to you, so that we will go with this question for today's lecture, because I want to explain this nodal analysis also. Is it clear to every one of you? Please, yes. Very good. So we will wind up with this question. Please focus here. Determine the voltages at the nodes, right? So this question requires the nodal analysis, right? So yes, clear, right? Sir, how Samyukta is asking something. How to solve by short circuit method? Why you want to solve short circuit method? See, short circuit method, otherwise do one thing, Samyukta. Anyway, we have to discuss Thevenin theorem tomorrow. There I will explain short circuit method, open circuit method to get the R equivalent very easily. Don't worry about that, because we are in the process of discussion now. One by one it will come. Okay. So, but remember one thing, that by the end of the lectures, you don't require to do this much. Easily you can get, very easily. But as it is the basic section, I am going with this. Okay. Sir, we want the shortcuts and speed cuts to do fast. Yes, yes, surely we will do it. Okay. In fact, the most important shortcut is the common sense. And after explaining all these concepts, I will tell you that you don't require to use all these things. But I will definitely explain with the shortcuts, believe me. Okay. But because there are so many students, we need to cover everyone, right? So here, the question is all about, finding the node voltages. So we have first node here, second node here, and the third node here. So the very simple way is apply KVL at each and every node, because we are in nodal analysis. Remember, whatever the approach we are applying in this, more or less you can apply nodal analysis to every question. Means KVL to every KCL to every question. So first of all, let us take node 1, right? Apply KCL to node 1. Apply KCL to node 1. Clear? How we can apply KCL to node 1? So very simple way is, assume that all currents are going out of the node. All currents are going out of the node. Clear? So then algebraic sum of all those currents equal to 0. This is called second form of the KCL. There are two forms of the KCL, two different ways to approach the KCL. First is sum of algebraic currents entering to the node equal to sum of algebraic currents leaving out of the node. That is the first approach. When we don't know what is the direction of current, then better to assume that that is the supreme node and all currents are leaving out of the node. Now this is, I am considering as the supreme node and assuming that all currents are leaving out of this node. So let me call this as I1, and he himself told that this is Ix here, and let me call this as a I2 here. Clear? So if I apply KCL at node 1, then I should go like this. First I1, sum of all these currents, I1 plus I2 plus Ix, that must be equal to 0. Algebraic current of all the currents will be equal to 0. Clear? So then tell me now, how do I approach here once again? Right, I1 is what? I1 is V1, look at that. This is V1 here, and here we have a ground, 0 volt. So anyway, that is a current, right? So we don't require current itself, it is given there. So the best option is I1 could be simply written as -3 ampere. Clear? And plus, what is I2 here? I2 is the current that is flowing all the way like this, correct? This is the direction of I2 here and the direction of I2 here, correct? And this is 3 and this is 3, node 3, and this is the first node. So how can I write I2 here? I2 is the voltage difference divided by resistance. What is the voltage difference between node 1 and node 3? Node 1 and node 3 voltage difference is V1 minus V3 divided by 4. Simple. Ix is what? Ix is the current that is flowing in this branch, right? In this branch. In this branch means it is going from 1 to 2 here. So therefore I can say V1 minus V2 divided by 2, that would be equal to 0. Clear? Right. So, and one more important thing I would like to see. There are so many questions I have discussed in my recorded lectures. If anybody want to practice so many questions like this, because now only I understood that many of you seriously really enjoyed a lot. If you want to enjoy more and more questions, go through the recorded lectures, don't miss that, because I have discussed almost more than 200 to 300 questions. Okay, and all questions are designed by me. I have not used any PYQs. I have designed the questions and solved that. So that will be a great adventure to you actually, right? So let me go with this one, right? So now the best part is multiply with the 8 everywhere. So you will be having minus 24 here plus. So 2 times of V1 minus V3 here, right? Plus 4 times of V1 minus V2, all put together, that is equal to 0. So what is this one? This is 6V1 and minus 4V2 and minus 2V3, and all put together this is equal to 24. So let me call this as equation 1 here. Clear? That is the first equation, right? So great, sir. Thank you very much, Upendra. So that is the first one. Now what I do is, let me take up this equation, because that's required here. See, if you are more than appreciation, I want you guys to practice more and more, get benefit out of it, right? So anyway, I have been teaching from last 12 years. So many students have appreciated me, but I want your result finally, and you should score well and get into IIT or NIT or PSU. Then as a teacher, we will be at most happy, right? So, but don't forget, once you get into PSU or IITs or NITs, okay? So this is the first equation, and then come to the second one, that is again, once again apply KCL, apply KCL once again at node 2. Clear? So how do we apply KCL at node 2 now, right? So simple again, easy way to get that. Right, now forget about this nonsense here. So these things are not required now, because we have already done with this, right? So node 2, again when we are applying KCL at node 2, the best part is assume that the node 2 is the supreme node compared to all other. Then what should I do here? Now if node 2 is the supreme node, without any second thought I should say that this could be written as now I1 here. Let me call this as I1, I2 and I3 here. Again now we can apply once again and write down this as I1 plus I2 plus I3 is equal to 0. But I1, what is I1 here? I1 would be written as V2 minus V1, because we have assumed that I1 is flowing from V2 to V1. This is our assumption. Later we will convert that and make as a minus Ix. That is a separate story. V2 minus V1 divided by 2. And plus, what about I2 here? I2 is going from 2 to 0. Correct? So V2 minus ground, that is 0, divided by 4, plus what is I3 here? I3 is V2 minus V3 divided by 8 here. Simple. That is equal to how much? 0. Okay. So again 8 we can take out here. So 4 times of V2 minus V1 plus 2V2 and plus V2 minus V3. Guys, you must be very good with this calculation and fast also. Okay. Right. So from here 4V2, 2V2 and V2, 7V2. So all put together I can say minus 4V1 plus 7V2 and minus V3, all put together, that is equal to 0. This is your second equation. So let me take up this one and write the second equation here. All of you please check your equations, because that is very important at the end, right? So minus 4 times of V1 and plus 7 times of V2 and minus V3, all put together, that is equal to 0. This is the equation number 2. And then come to the third one, that is apply KCL for the third equation. And third is little bit dangerous one, so be careful with the third application, because I know many of you might be really wondering about the third, right? So apply KCL at node 3. So if you apply KCL at node 3, what will going to happen here? So at node 3, if you look at, again, the best part is first remove all this nonsense here, whatever is there here. So this is not required. Remove this one here. And then again, some algebraic sum of all the currents equal to 0. So I can take, I1 here, and let me call this as I2 here, and let me call this as a I3 here. And that I3 is anyway flowing in this way. Again, algebraic sum of all the currents equal to 0. 4.8, 2.4, minus 2.4, good. Right? So I can say I1 plus I2 plus I3 equal to 0. I1 plus I2 plus I3 equal to 0. What is I1 here? I1 is V3 minus V2 divided by 8 ohm plus I2 is what? I2 is simply like 2 times of Ix. 2 times of Ix. That is I2. Instead of writing 2 times of Ix, as I know Ix is flowing from 1 to 2, I can say this as V1 minus V2 divided by 2 here. Simple. Plus I3. What is I3 here? I3 is V3 minus V1 divided by 4. That must be equal to 0. Simple. Correct? So then 2 get cancelled here. So then what should I say here? Yes, 2 is not required here. So simply like V1 minus V2. And here from this we can say V3 minus V2 plus 8 times of V1 minus 8 times of V2 plus 2 times of V3 minus 2 times of V1 is equal to 0 after LCM. Then what is the third equation? Third equation is minus 2 times of V1 plus 8 times of V1. How much that will be? 6 times of V1. Excellent, right? No problem. So this I have covered. And V2. So it is minus 9 times of V2. Look at that. This is also covered here. 2V3 plus V3. So that is going to be plus 3V3 equal to 0. This is going to be the third equation. Clear? So now you can use any of your methods, whatever you know. You can take calculator or you can use matrix algebra, anything, I don't care really. Use any of the procedure you know and try to get the answer for this one. Clear? So yes, very good, very good, very good. Cramer's rule. See, that is up to you. You can use Cramer's rule, Brammer's rule, anything, no problem, right? But these are the 3 equations you need, and you should solve this to get the values of V1 and V2 and V3. And I sincerely request every one of you, solve this and keep your answer after the live session in the comment section. You have to answer this V1, V2, V3. Then I really like it, and I will keep those who have answered very well. I will publish their result name in the next live session, and you have to solve this V1, V2, V3 and keep me in the comment section. Okay. But I would like to agree with one fact, that most of you have done really very well. See, this is a first class for me in this champion series. So now I understood your capabilities. Tomorrow we will going to see more and more shortcuts. Not shortcuts, basically. You will see the way how I solve, because this is the way how I teach it to the students. But obviously I solve in a different level. Correct? So by the end of these 4 days, I will show you the way how I solve, how I topped 10 times GATE examination, more than 10 times, right? So by 4 days of this lecture, you will understand the way how I am going to think. But again, I am requesting you, if you want my complete series of lectures on circuit theory, I sincerely suggest go back to BEP app and watch the recorded lectures. And transients, which is considered as the most difficult topic in the circuit theory, I have explained in the easiest way. So don't miss at all anything. Tomorrow we will going to mostly address theorems. Along with that, I will also explain some of the shortcuts also. Shortcuts in the sense, without using any of the big techniques, how do we get the answer in the very fast way? That is the discussion in tomorrow's session. So tomorrow, don't miss the session, but I want you to take the homework, these questions as a homework. So please, sir, your Telegram, yeah, just go to the Telegram and mention like @ IN Guru. So Guru 22. See, I is capital, N is capital, G is capital. but you are small and 22. Just type like this. You will going to get my Telegram group. You can join there and enjoy the discussion, right? Quality factor, random circuit ka kaise. Yes. See, already we have covered so many things, right? So better what we will do is, we will go more and more discussion about the shortcuts and the other topics from tomorrow's lecture onwards. It is almost around 1 hour 20 minutes. I want you to solve, take these questions and do practice and get the solutions of this after the live session. Try to keep your answers in the comment section. Then I will feel that yes, you are following, and then I will get more and more new questions. Okay, right. So today was a wonderful session. Yeah, very much. Even I really enjoyed a lot with you guys, because more than I expected. You people are very smart. I am frankly agreeing that. But let us continue the same harmony of the discussion in the upcoming lectures also. By the end of the lectures, more than the concept, you should take my thinking approach. That is more important. Clear? So, well, that's all about for the today's session. We will once again meet in tomorrow's session at the same time, 9 p.m. Don't miss the class. We will meet once again. Thank you very much, guys. Enjoy.